In this video, I'm going to show you how you can find the formula and therefore the nth term of a quadratic sequence. And I've got here a sequence. And we don't know yet that it's a quadratic sequence, and we're going to show that. And so the first thing we need to do with any sequence is we would find the differences, and that gives us a really big insight into the behavior of the sequence. So the first thing we do is we find the difference between the first two numbers, so 2 and 7. That is a difference of 5. Then between 7 and 16, we get the difference of 9. Between the next numbers, we get a difference. And then between 29 and 46, we get a difference of 17 by subtracting the numbers. We can see that those are not the same. So this tells us we don't have a simple sequence, we have a more complicated sequence. In this case, it's a quadratic sequence because the difference of the differences is going to come to the same number. So let's find the difference between the second row of numbers. So 9 minus 5 would give us 4. 13 minus 9, same thing. And then 17 minus 13, that gives 4 again. So we have, in this case, a quadratic sequence because the second difference, that's the difference of the differences, is all the same. There is a general formula that we can apply and use 3 simple formulae along with the general formula to work out very easily the formula for a quadratic sequence. So the formula we need is that sum a times n squared, n is like the number of the term, so n is 1 is the first term, n is 2 is the second term, n is 3 is the third term, plus some value b times our n plus a constant c. We don't know what A, B, and C is, so we need to find what A, B, and C is. And there's 3 formulae that we can use in order to do this, and it's going to use the numbers we've worked out before. So it turns out that the difference of our differences, or the second difference, is actually equal to 2a. So we can set 2a equal to 4. Well, that's not very difficult to solve, so that tells us that a is 2. So we found one of our 3. We need A, B, and C. We've already found A. So we know that A is 2. We could then replace A in our general formula with 2. So we're one step towards getting the answer. We don't know what B is, though. We need to find the value of B. And B is actually linked to our first number here. So the 3A plus B is equal to 5. So we're going to have 3 formulae. This is the second of it. And it's a good idea to memorize and learn these formulae, because they will actually allow you to solve these problems very, very quickly. So we've got 3a plus b is equal to 5 that we've just extracted. We already know that a is 2, so we can substitute. And then by simple rearrangement, we can work out that b is minus 1. So we now have the second term. So we can replace b on our list with minus 1, and then we can substitute b equals minus 1 into the equation. The last thing we need is c. And it turns out that we have another formula, which is that a plus b plus c is equal to our very first number there. So we can set that equal. We already know what a is. We already know what b is. We just worked them out. So we can replace a and b. That means we only have to find c. Simple bit of manipulation, and we end up with c as 1. So we can replace c with 1. We can then finish off our formula by substituting. So we have a general formula. So this means for any value of n, we can work out what the value of the term is. So say we had a problem that said, what is the 10th term in the sequence? We'd take our formula we've just worked out, and we know it's the 10th term, so n equals 10. So we replace n with 10. We would then evaluate that, and we would end up with 191, and that's the answer. So this is a nice simple method that allows you to find the nth term and the general formula for a quadratic sequence very, very easily. If it was helpful, please like and subscribe. And finally, thank you very much for watching.